So these are density problems we're dealing with here, and the equation we'll be using for this particular unit will be density equals mass divided by volume. And looking at the first one, we're looking for the density. We've been given the mass, we've been given the volume. So density is going to equal 75 grams divided by 25 cc's. That's going to give us our final answer, 3.0 grams per cc. You can see how the units match here, grams over cc's. And you can see we've got 2 sig figs here, 2 sig figs here. So our answer is going to come out to 3 in the calculator, but it needs to be 3.0 to match the significant figures here. This 0 is significant because there's a decimal point in the number. Trailing zeros are always significant when there's a decimal point in the number. Alright, looking at the next one. We've got a certain object weighs 1.25 kilograms, has a density of 5.00 grams per mil. What we're looking for is the volume. If we know that density equals mass times volume, that means that mass equals density times volume, which means that volume equals mass divided by density. So we know that we've got volume is equal to the mass, which is 1.25 kilograms. I'll leave that for a second, and we've got 5.00 grams per mil. So in order to make this work out, we're going to have grams on top, so the grams cancel and leave us with mils. And since this is grams per mil and it's on the bottom, it'll flip up to the top. So we're dividing by 1 over mils essentially, so it'll be milliliters on top here. Now we've got 1.25 kilograms, that's not grams. I'm going to have to do a conversion here, and I'll do that by using our conversion factor, which is going to be 1 kilogram is 1,000 grams. So on top here we'll have 1250 grams. And we do the division here, it's going to come out to be 250 milliliters. This has 3 significant figures because of the 0 not being significant here. This has 3 significant figures. So our answer has to have 3 significant figures as well. The dot here makes this 0 at the end significant. So looking at the next one, a piece of lead occupies 200.0 mils, has a specific gravity of 11.4. Alright, so we know that the mass is going to equal density times volume. That's what we've got over there. So we'll do the same thing here. We've got density, and we don't have density. What we have here is specific gravity. Just to give you an idea of what specific gravity is. Specific gravity is the density divided by the density of the object divided by the density of water, which is 1 grams per mil. So if we wanted the density of the object, it would just be specific gravity multiplied by 1 gram per mil. So if we've got a specific gravity of 11.4, that means the density is 11.4 grams per mil. The volume is 200.0 milliliters. So you can see the milliliters will cancel, and it will lead us to our answer in grams. Now, the number of significant figures here, we've got 3 sig figs here, we've got 4 sig figs here, so the answer is going to come out to be 3 significant figures. This 0 here at the end is not significant, and it's not significant because there's no decimal point in the number.